Okay, so now we're moving on to finding the general formula for the n-termed geometric sequence. Okay, so coming into this video, I assume now you've already watched the previous videos where we talk about how to determine whether a sequence is geometric or not. Okay, so the formula for finding the n-term for the general formula for an n-term in a geometric sequence is given by Tn is equal to T1 then r to the power -1, where T1 represents the first term of the sequence and r represents the common ratio of the sequence. We talked about these two in the previous videos for geometric sequences. Alright, so I'll just make some few examples here, one or two. So if I'm given a sequence like 7, 14, 28, 56, we say this is a geometric sequence. Why are we saying that? Because the ratio between the consecutive terms is common. So if I say between 7 and 14, if I say 14 divided by 7, I get 2. So here is times 2. Between 14 and 28, 28 divided by 14 is also 2. So this is also times 2. Again, between 28 and 56, I'm saying 56 divided by 28, I'm getting 2. So also here is times 2. So the ratio between the consecutive terms is common, and it is common by 2. Hence we are saying R, which represents the common ratio, is equal to 2 in this area. So now from our formula here, we only need now to find the T1. T1 is easier. It's even more easy because T1 is just represents the first term, and the first term of the sequence is 7. This is the first term of the sequence. So we now have R T1. We also have R. So the formula would be then Tn is equal to T1 is 7. The 7. Okay, maybe let's make it like this. We're saying Tn is equal to T1 R to the power n minus 1. The formula here. Okay, now we substitute. Where is T1? I just plug the 7 here. So I will say 7. And then R will be 2. So I will say 2 to the power n minus 1. Alright, this is our answer. We'll leave it like this. We don't have to say 7 times 2 is 14 then to the power n minus 1. No, mathematically that is incorrect. So we just have to leave our answer like this. So I'm done. Okay. Please move on to another quick example. We're using the same concept. There's nothing new. Okay. So the examples that I will be using here are I already know that these are geometric sequences, so we are not focusing on determining whether the sequence is actually a geometric sequence or not. So let's say we have 4 with 12, then we have times 3, then we have 36. Okay, so I'm saying this is also a geometric sequence. Alright, I've tested that. Already I know that. Okay, but for your clarity, I will just tell that I'm saying that because between these first two terms, I have 12 divided by 4, which is 3. So here the common ratio is 3, and also between 12 and 36 divided by 12, I also have 3. So here we also have 3. So by the fact that the ratio between the consecutive terms is common, we are now saying, or let me say it's the same. We are now saying this sequence is a geometric sequence, and we call this 3. We call this 3. We call this 3 the ratio. So we're saying R is equal to 3. Alright, so we have R, and also we now have to find T1. and T1 says the first term is 4. So yeah, okay, we have R, we have 4, we also have T1, so we plug it into our formula. We're saying Tn is equal to T1 and then R to the power n minus 1. Tn is equal to, the first term will be, the first term is 4, then R is equal to 3, so 3 to the power n minus 1. So we are done.